Oceans, these immense bodies of water, cover most of our planet. But how deeply have we truly plumbed their mysteries? Today we'll dive into the most abyssal and least explored corners of the global ocean to reveal astonishing facts that may have previously remained unknown. The ocean isn't 5 separate bodies of water. It's a single, interconnected system known as the world ocean. It stretches across more than 70% of Earth's surface, spanning an area of 361 million square kilometers. This colossal volume of salt water links continents and plays a crucial role in regulating the planet's climate. Without its existence, life as we know it would be inconceivable. The total volume of water contained within the ocean is approximately 1.3 billion cubic kilometers. If all the land on the planet were perfectly flat, this water would cover it with a layer more than 2.5 kilometers high. It is truly a magnificent water reservoir. Salinity is a key characteristic defining the ocean's essence. On average, 1 liter of ocean water contains 35 grams of dissolved salts, with common table salt making the largest portion. If all the salt from the ocean could be collected and evenly spread across the land, it would cover all continents with a layer 150 meters high, comparable to the height of a 40-story building. The average depth of the ocean reaches almost 4 kilometers, while its deepest point, known as the Mariana Trench, plunges more than 11 kilometers down. This is significantly deeper than the height of Mount Everest. Imagine the world's tallest peak submerged in the trench, with still a couple of kilometers of water above its summit. Sunlight penetrates the ocean to a depth of only about 200 meters. This area is called the euphotic zone. Below it, a twilight realm begins, and from a depth of 1 kilometer, eternal, impenetrable darkness sets in. This perpetual darkness encompasses 95% of the ocean's entire volume. The Pacific Ocean is the largest of them all. It covers almost a third of the planet's entire surface. Its area surpasses the combined total area of all Earth's land masses, which is truly difficult to imagine. It is also the oldest of the ocean basins, with its rocks dating back up to 200 million years. It was named the Pacific because Ferdinand Magellan, during his circumnavigation, crossed it in 3 months and 20 days without encountering a single storm. He was incredibly lucky, as this ocean is usually anything but peaceful. It is in the Pacific Ocean that the famous Ring of Fire is located. This zone accounts for about 90% of all earthquakes worldwide, and is home to over 75% of all active volcanoes. It is one of the most geologically active places on the planet. Also located here is the most isolated point on the planet, Point Nemo. This is the oceanic pole of inaccessibility. The nearest land is over 2,600 kilometers away. It is so remote that the closest people to Point Nemo are often astronauts on the International Space Station. Point Nemo is also used as a spacecraft graveyard. Old satellites and space stations, such as the Mir station, are deliberately deorbited and sunk there. The calculation is designed to ensure debris falls far from people and shipping lanes. The Pacific Ocean is also home to the Great Pacific Garbage Patch. This is not an island made of plastic bottles, as many mistakenly believe. It's more like a giant soup of microplastics suspended in the water. This vast area causes serious harm to marine life by entering their food chains. The Atlantic Ocean is the second largest. It is relatively young, having begun its formation about 180 million years ago, when the supercontinent Pangaea broke apart. And unlike the Pacific Ocean, which is slowly shrinking, the Atlantic Ocean continues to expand. The main feature of the Atlantic is the Mid-Atlantic Ridge. This gigantic underwater mountain range stretches from north to south almost across the entire ocean. Its length exceeds 16,000 kilometers. It is the longest mountain range on Earth, and it is almost entirely hidden underwater. This ridge is part of a global system of underwater ridges 65,000 kilometers long. Iceland is one of the few places where this ridge emerges to the surface, which explains its volcanic activity. Along this ridge, the Earth's crust is constantly spreading apart, and magma erupts from the fissures, creating new ocean floor. Because of this, North America and Europe are moving away from each other at a rate of approximately 2.5 centimeters per year, the speed at which your fingernails grow. The Bermuda Triangle is also located in the Atlantic. While most stories about it are myths and exaggerations, this area is indeed challenging for navigation. Sudden storms are frequent here, and Earth's magnetic field exhibits some anomalies that may have confused navigational instruments in the past. Also in the Atlantic is the Sargasso Sea. This unique sea has no land boundaries. Its borders are defined by 4 clockwise rotating ocean currents. It is famous for its floating sargassum seaweed, which forms vast mats on the surface, creating a unique ecosystem. The Indian Ocean is the third largest and the warmest of all. Due to its location and relatively enclosed northern part, its waters do not mix well with colder polar waters. This affects its ecosystem and, of course, the regional climate. A unique feature of the Indian Ocean is its monsoons. These are seasonal winds that dramatically change direction twice a year. In summer, they blow from the ocean to the land, bringing torrential rains, while in winter they blow from the land to the ocean, bringing drought. This system dictates the lives of hundreds of millions of people. The Indian Ocean harbors a remarkable gravitational anomaly known as the gravity hole. This vast region, stretching 3 million square kilometers, is characterized by significantly weaker Earth's gravity compared to average levels. The sea level in this peculiar depression is approximately 100 meters lower than in other parts of the world ocean. For decades, this geoid low remained an unsolved mystery for scientists. However, recent research suggests its formation is likely linked to the movement of lighter magma in the Earth's mantle, lying deep beneath the ocean floor, a legacy of an ancient tectonic plate. These waters are home to truly unique creatures, such as the coelacanth. This fish was long thought to have vanished with the dinosaurs until it was discovered off the coast of South Africa in 1938. The coelacanth is a genuine living fossil, having remained virtually unchanged for millions of years. The Arctic Ocean rightfully holds the title of the smallest, shallowest, and coldest of all the world's oceans. For most of the year, its expanses are locked in by drifting sea ice, although the area of this ice cover has been rapidly changing in recent decades. It is almost entirely surrounded by land, the vast territories of Eurasia and North America. This geographical feature gives it the resemblance of an inland sea, connected to the Pacific Ocean by the narrow Bering Strait and to the Atlantic by a wider passage. Beneath the Arctic ice lie colossal reserves of natural resources. However, even greater interest is sparked by its unique ecosystem. Life here has adapted to extremely harsh conditions. For instance, algae can be found growing directly on the underside of the sea ice, where sunlight penetrates. Despite the unfavorable environment, life thrives here. Polar bears, seals, walruses, and in the underwater depths, narwhals, these sea unicorns with their famous tusk, and bowhead whales. These colossal mammals can live for over 200 years, making them the longest living creatures on the planet. The Southern Ocean is the youngest among officially recognized oceans. It was designated only in 2020, although oceanographers had long spoken of its distinctiveness. It encircles Antarctica. Its key feature is the Antarctic Circumpolar Current, or west wind drift. This is the most powerful current on the entire planet. It moves from west to east around the entire continent, encountering no land masses in its path, which allows it to gain colossal strength. This current transports 100 times more water than all the world's rivers combined. It acts as the engine of the global conveyor belt of ocean currents and forms a unique barrier, isolating the cold waters of Antarctica from warmer waters flowing from the north. This ocean is also known as the stormiest. Winds here can reach hurricane force, and waves can exceed 20 meters in height. It is one of the harshest places on Earth, yet it teems with life, especially krill. Krill are small crustaceans. They form swarms of such density that they can be seen even from space. Experts estimate that the total mass of krill in the Southern Ocean exceeds the mass of all humanity. Whales, penguins, seals, and fish feed on this krill. Now, let's turn to the question of depth. The Mariana Trench is the most famous deep-sea location on Earth. The first human dive to its bottom occurred in 1960 aboard the bathyscaphe Trieste. Jacques Piccard and Don Walsh spent 20 minutes there. They were astonished to discover a live fish resembling a flounder, about 30 centimeters long, at the bottom. This discovery conclusively proved that complex life could exist even under monstrous pressure. The pressure there is 11,100 times higher than at the surface. This is comparable to having a stack of 50 passenger airplanes placed on a person. The water temperature barely exceeds freezing, and absolute darkness reigns. It would seem impossible for life to exist in such conditions, yet it is present. In 1977, scientists made an astonishing discovery. They found hydrothermal vents, or so-called black smokers. These are true underwater geysers. They spew superheated, mineral-rich water at temperatures up to 400 degrees Celsius. Around these vents, life flourishes, forming unique oases in the midst of an icy desert. These ecosystems do not depend on sunlight. Instead of photosynthesis, chemosynthesis thrives here. Bacteria use hydrogen sulfide, which is toxic to us, from the vents to produce energy. These bacteria are fed upon by giant tube worms, blind crabs, and other unusual creatures. There are also cold seeps. These are places where methane and hydrogen sulfide slowly seep from the sea floor. Unique chemosynthetic ecosystems have also formed there, but with different species, such as giant mussels, which live in symbiosis with bacteria. The ocean is the cradle of life, and much of this life remains unknown to us. Scientists believe that we have explored less than 10% of the ocean, and we know even less about deep-sea species. It is quite possible that up to 80% of the species living in the ocean have yet to be discovered. In the depths, where sunlight cannot penetrate, many animals use bioluminescence, the remarkable ability to glow. This light is used for hunting, camouflage, or attracting a mate. The ocean depths are a constant spectacle of flashing lights. Here, anglerfish are found with a fishing rod on their heads containing glowing bacteria. Some squid can release a cloud of glowing ink to blind a predator. And there are creatures that have become completely transparent to hide in the water column. We know of giant squid, or Architeuthis. For decades they were considered a myth, but now we know for certain they exist, reaching 13 meters in length. They engage in epic battles with sperm whales in the depths, as evidenced by characteristic suction cup scars on the whales' bodies. There is also the viperfish, whose teeth are so large they don't fit in its mouth even when closed. And then there's the vampire squid from hell, a creature that is neither a squid nor an octopus, but something in between, inhabiting zones with minimal oxygen content. Ocean waters can sometimes have low oxygen levels. Scientists are only beginning to understand the phenomenon of deep-sea gigantism. This astonishing process involves certain species, such as crustaceans or isopods, living at significant depths, reaching colossal sizes compared to their shallow water relatives. The reasons for this phenomenon are still not fully understood. It is hypothesized that this characteristic may be due to the effects of low temperatures and high pressure. The global ocean is a treasure trove, not only of biological mysteries, but also a true realm of sounds. One of the most famous phenomena was the bloop. This powerful, low-frequency sound was recorded in 1997. Its intensity surpassed the noises of any known inhabitant of the planet, including the blue whale. Initially, hypotheses about a giant sea monster were put forth, but scientists later concluded that the bloop was most likely the sound of an ice quake, the characteristic cracking and colossal breaking of giant icebergs as they calve from Antarctic glaciers. However, other unexplained sounds have also been recorded. Slow, train, Julia. Most of these are currently associated with ice mass dynamics, but this testifies to the unprecedented acoustic activity of the ocean and how superficial humanity's understanding of its language has been. How many more secrets does the ocean floor hide? It is estimated that the remains of over 3 million sunken ships rest on its vast expanses. This represents thousands of years of maritime history, spanning from ancient Greek galleys to World War II vessels. A significant portion of these relics remains undiscovered. Beyond countless shipwrecks, entire ancient cities lie hidden on the ocean floor. Examples include parts of ancient Alexandria in Egypt, which submerged, or the city of Pavlopetri in Greece, the oldest known sunken city, dating back about 5,000 years. There are also many geological mysteries, such as the Bimini Road, located off the Bahamas. It consists of underwater stone blocks arranged in an orderly row. Many researchers are inclined to consider them a man-made structure, possibly even part of an ancient civilization. But most geologists firmly assert that it is merely a natural rock formation. The ocean represents not just a body of water, but the true lungs of our planet. Phytoplankton, these microscopic algae, produce 50 to 80% of all the oxygen humanity breathes. This volume significantly exceeds the output of all terrestrial forests. Among phytoplankton, Prochlorococcus stands out as the smallest and most widespread photosynthetic organism on Earth. Every second breath a human takes is a direct result of their tireless activity. Furthermore, the ocean performs the vital function of the planet's giant thermoregulator. It absorbs colossal amounts of thermal energy from the sun and then redistributes it across the planet through powerful currents, one of which is the Gulf Stream. Without this process, the climate in some regions of the world would be unbearably hot, while others would be locked in ice. There is also the global ocean conveyor belt, a complex system of water flows that redistributes thermal energy across the planet. Cold and salty water sinks at the poles, moves along the deep sea floor towards the equator, where it gradually warms and rises back to the surface. A full cycle of this massive process takes about 1,000 years. The global ocean also absorbs approximately a quarter of all carbon dioxide emitted by humanity into the atmosphere. This process undoubtedly mitigates climate change, but it comes with a certain cost. The water becomes increasingly acidic, This acidification creates significant difficulties for the survival of organisms whose shells or skeletons are made of calcium carbonate, such as corals, oysters, and certain types of plankton. Such a phenomenon poses a colossal threat to the entire marine food web. The world ocean remains the last great and virtually unexplored territory on planet Earth. Humanity possesses significantly more information about the landscapes of Mars and the Moon than about the deep-sea trenches of Earth's oceans. Every new dive, every research expedition brings groundbreaking discoveries that fundamentally change our understanding of life. Researchers have only just touched the tip of the iceberg. Beneath the water's surface lie gigantic mountains, deepest canyons, boundless underwater deserts, and oases of abundant life, eagerly awaiting their discoverers.